Dear students, it is the motion that makes the world go round. It is a motion that keeps us alive. It is a motion that forms the base of all the sciences. Today we are going to learn about this particular aspect of science, which is motion. So, as I said, we are going to learn a part of force and laws of motion, and that part is inertia and mass and second law of motion. These two topics we are going to study in detail today. So, before starting with part 2 of this chapter, let me remind you what we studied in the last session. We studied introductory section of the chapter. We studied about balanced and unbalanced forces, and we also studied about first law of motion. All these three topics we had covered in the last session. And what we are going to study today? Today we are going to start with inertia and mass. What is inertia? Inertia is nothing but a tendency of an object to resist the change in the position. So whenever we try to apply a force on any object, it tries to resist its change in position. This resistance is called as inertia. Now, to understand inertia, let us imagine a glass and a card and a coin. You have to place a card on the glass and a coin on the card. And then what you have to do is push the card with the tip of your fingers swiftly. What will happen? Our logic says that coin and card will move further in forward direction. However, in real life what happens is card moves further but coin falls into the glass. Why? Because coin is massive than card and it resists the change in its position, so it falls back into the glass. So what do we conclude? On a funnier note, we can think that the science doesn't follow our logic, because logic, what does it say in this case? It says that coin and card will move further in the forward direction. However, coin falls into the glass. So this nature of the masses doesn't follow our logic. Let us move further. Heavier or massive objects offer more inertia. So heavier the object, it will offer more inertia. In other words, inertia depends on the mass of the object. Thus, inertia is a natural tendency of any object to resist a change in its state of motion or of rest. So, if someone asks you what is inertia or define inertia, then you have to write this statement. What is the statement? Inertia is a natural tendency of an object to resist a change in its state of motion or of rest. Now we are going to study second law of motion. If we want to accelerate an object, we need to increase the applied force to give it a greater velocity. For example, I have shown here a picture of cheetah. What does cheetah do to accelerate himself? What does he do? He applies a force on the ground, and then ground helps him to move further. And greater the mass, greater is the force required. For example, elephant can't run with the speed of cheetah. Why? Because he has a greater mass. Thus we can conclude that mass and velocity are related to each other. This property that relates mass and velocity is called as momentum. So here this picture belongs to that of the Newton's cradle. Newton's cradle is many times used in the study of collision, and in collision momentum plays an important role. So this was introduced by Sir Isaac Newton, and This picture also is named as Newton's cradle because we used to study this instrument to study his theory in physics. The momentum of the object is defined as the product of mass and velocity. So mass, if it is m and v is velocity, then p, which is momentum, is equal to mass into velocity. Now, the second law of motion states that a rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. So what is second law of motion? As per this law, rate of change of momentum is directly proportional to applied force and it happens in the direction of force. Students, now we are going to derive a relation for force using this law of motion. So let us see a mathematical formulation for force. Suppose an object of mass m is moving along a straight line with the initial velocity u. Okay, so initial velocity is what? U, and mass is m, and it is moving in a straight line. It is uniformly accelerated to velocity v in time t by application of a constant force F throughout time t. So what is final velocity? Final velocity is v. The initial and final momentum can then be given as momentum, as you know the formula, mass into velocity, but here in this case there are two velocities. One is initial, which is u over here, and another is final, which is v. So what will be the formula for initial momentum? If I take it as p1, it will be p1 is equal to mu, and p2, if it is final momentum, then it can be written as m into v. Let us move further. The change in momentum. What will be the change in momentum? It will be final momentum minus initial momentum. So it will be P2 minus P1. And what is P2 minus P1? mv minus mu. Now here in this case, mass is common in both the terms. So you can take it outside the bracket, and inside the bracket there will be v minus u. So change in momentum is mass into v minus u. So what will be the rate of change of momentum? It will be proportional to m into bracket v minus u divided by t, because it is time rate of change of momentum. Now comes into the picture force. So as per second law of motion, force is proportional to rate of change of momentum. So F is proportional to m v minus u upon t, because this is rate of change of momentum and this is force. So as per second law, F is proportional to, or applied force is proportional to, rate of change of momentum. So mv minus u upon t, m into bracket v minus u upon t. Now since it is proportional, it will be equal to some proportionality constant into the term in the bracket, which is m into bracket v minus u upon t. So this k is proportionality constant. Now this value of k, it is, I will tell you what is value of k, but before that let me show you what is this term in the bracket. So what is m v minus u upon t? This v minus u upon t is nothing but change in velocity with respect to time, which is nothing but acceleration. So now this equation becomes F is equal to kma. Now k, value of k is 1, so you have to replace k with 1. So what will equation become then? F is equal to ma, that is force is equal to mass times acceleration. So this is our final relation for force. Do you know what is unit of force? The unit is newtons, or you can also write it as kg meter per second square, because this m standard unit is kg and acceleration unit is meter per second square. So you can write it as kg meter per second square, but most of the time we use Newton as the unit of force. Well, that was all for today. Now that we know few things, you can try some things at home. So first question is, what is inertia? Second is what is momentum. Third is state Newton's second law of motion. And fourth is derive relation for force using Newton's second law of motion. I will repeat the questions. First question is what is inertia? Second is what is momentum? Third is state Newton's second law of motion. And the final question is derive relation for force using Newton's second law of motion. So these are the four questions, and topics related to these questions have already been discussed, so you will find it easy to answer them. I hope you understood today's session. If you have any doubts, feel free to ask. See you in next session. Until then, take care. Bye bye.